Boys, welcome to the stream. How y'all doing? I know none of y'all are here yet because I'm not that popular, but we are doing the stream. No, wait a minute. Today, the RTX 5060 will be unveiled. And the reason why I'm streaming this, and I didn't stream any other launches of the graphics cards, is because the 5060 was the card that I was going to buy. So today, on this day, I'll find out what this 5060 will look like. In an alternate timeline, I would be adding this graphics card to my card and then installing it in my computer. But this is this timeline instead of the alternate timeline. So let's see what I missed out on or what I didn't miss out on. Let me really quickly go to see what the I need to change that. Okay, wait a minute. Just I'm gonna have a BRB screen probably eventually, but okay, there we go. Alright, I have fixed the stream. Computex stream. Oh. I can't read that. I did learn Japanese a little bit, but I did not. Oh. Yes, this message. I approve of this message. Jensen. See this. Wait, why is it so?
智慧就是这样制成的。
What the fuck?
一种新型的工厂，制造 tokens， 人工智慧的基石。
Okay, that's AI number one.
Tokens 开拓了一个新领域，带人们步入非凡世界，孕育无限的可能。
Oh my.
tokens 将图像化为科学数据，描绘宇宙天文，引领未来的探索者。在地球上，它复印我们的城
Why is it
市，
so low quality?
帮助我们克服今日的困难。
Dude, is it just me or does the stream look like ass? Okay, this doesn't look like ass. But
tokens 揭发物理定律，让我们更快抵达目的地。
is it just me or does the 4 hours and 20 minutes nice look like really low quality?
并且不断向前。
I don't know. This whole AI thing I don't
tokens
like.
可以提前发现疾病的征兆，
The only thing I like about AI
助
is
我们揭
the
开生命的奥秘。
prompt stuff, not image generation or anything like that. Let's see how much BS
他
he
们
will.
研究人体动作，协助我们达到最佳状态，
Let's see how much he will spit now.
还将现实带入虚拟世界。
Oh, this is motion capture.
他们助我们精进技能。
有瑕疵的电路板在右边，需要我帮你拿去修理吗？好的，
Average factory
谢
worker.
谢。
tokens 不仅教会机器人如何行动，还给世界带来欢乐。
请把这些送到护理站。
为我们提供助力。
Just hire a bunch of kiddos. There's probably a bunch of kiddos behind them.
并让美好生活触手可及。
What? What if the robot starts jorking it?
让我们携手并进，勇敢探索人类未曾想象的可能。
Yo, chat, should I do a face reveal whilst this is happening? Probably not. I don't have that much fame.
这一切
It's the
都
funny.
从这里开始。
It's the Apple building. Oh.
女士们、先生们，欢迎 NVIDIA 创办人暨执行长黄仁勋先生。
Welcome to the stage, NVIDIA founder and CEO,
Jensen
Huang.
Huang. Is it gonna be you liking my jacket? Yo, it's Jensen. It's the 62-year-old. He's never sprinted in his life. Only time he sprinted was when he was at Denny's. All right, let's see this iPhone. Hello. Hello, Jensen. I know you. What? Oh, look at that! His new leather jacket.
It's great to be here. My parents are also in the audience. 我爸妈妈来，他们在哪里？ They're up there. NVIDIA has been coming to Taiwan for over 30 years. This is the home of many of our treasured partners and dear friends. Over the years,
MSI.
you have seen NVIDIA grow up and seen us accomplish many exciting things and have been partnered with me all along the way. Today, we're going to talk about where we are in the industry, where we're going to go, announce some new products, exciting new products and surprising products that open new markets for us,
What time is it?
creates new markets,
Jeez.
new growth. We're going to talk about great partners and how we're going to develop this ecosystem together. As you know, we are at the epicenter of the computer ecosystem, one of the most important industries of the world. And so it stands to reason when new markets has to be created, we have to create it starting here at the center of the computer ecosystem. And I have some surprises for you.
Let's see it.
Things that you probably wouldn't have guessed.
No.
And then, of course,
Let's see.
I promise I'll talk about AI.
Oh, no!
And we'll talk about robotics. The NVIDIA story is the reinvention of the computer industry. In fact, the NVIDIA story is also the reinvention of our company. As I said, I've been coming here for 30 years. Many of you have been through many of my keynotes. Some of you, all of them. And just as you reflect on the conversation, the things we talked about in the last 30 years, how dramatic we changed. We started out as a chip company with a goal of creating a new computing platform. And in 2006, we introduced CUDA, which has revolutionized how computing is done. In 2016, 10 years later, we realized that a new computing approach has arrived. And this new computing approach requires a reinvention of every single layer of the technology stack. The processor is new. The software stack is new. It stands to reason the system is new. And so we invented a new system that on the day I announced it at GTC 2006, no one understood what I was talking about, and nobody gave me a PO. That system was called DGX-1. DGX-1, I donated the first one to a nonprofit company called OpenAI. And it started the AI revolution.
Wow.
Years later, we realized that in fact, this new way of doing software, which is now called artificial intelligence, is unlike traditional ways of running software. Whereas many applications ran on a few processors in a large data center, we call that hyperscale. This new type of application requires many processors working together, serving queries for millions of people. And that data center would be architected fundamentally different. We realized there were two types of networks. One for north-south, because you still have to control the storage, you still have to have a control plane, you still have to connect to the outside. But the most important network was going to be east-west. The computers talking to each other to try to solve a problem. We recognized the best networking company in east-west traffic for high-performance computing, large-scale distributed processing, a company that was very dear to our company and very close to our heart, a company called Mellanox, and we bought them 5 years ago, 2019. We converted an entire data center into one computing unit. And you heard me say before, the modern computer is an entire data center. The data center is a unit of computing. No longer just a PC, no longer just a server. The entire data center is running one job. And the operating system would change. NVIDIA's data center journey is now very well known. Over the last 3 years, you've seen some of the ideas that we're shaping and how we are starting to see our company differently. No company in history, surely no technology company in history, has ever revealed a roadmap for 5 years at a time.
AMD.
No one would tell you what is coming next.
AMD.
They keep it as a secret, extremely confidential. However, we realized that NVIDIA is not a technology company only anymore. In fact, we're an essential infrastructure company. And how can you plan your infrastructure, your land, your shell, your power, your electricity, all of the necessary financing around all over the world? How would you possibly do that if you didn't understand what I was going to make? And so we described our company's roadmap in fair detail, enough detail that everybody in the world can go off and start building data centers. We
Isn't
realize now
power-wise.
we are an AI infrastructure company.
I don't like that.
An
though.
infrastructure company that's essential all around the world.
Okay, and
Every region, every industry, every company will build these infrastructures. And what are these infrastructure? These infrastructure, in fact, not unlike the first industrial revolution, when people realized, GE, Westinghouse, Siemens, realized that there was a new type of technology called electricity, and new infrastructure has to be built all around the world. And these infrastructure became essential part of social infrastructure. That infrastructure is now called electricity. Years later, this is during
AI.
all of our generation, we realized there was a new type of infrastructure. And this new infrastructure was very conceptual, very hard to understand. And this infrastructure called information.
oh,
This information infrastructure, the first time it was described, made no sense to anybody. But we now realized it is the internet. And every internet is everywhere. And everything
love
is
the
connected
internet.
to it. Well, there's a new infrastructure now. This new infrastructure is built on top of the first two.
it's
And this
AI.
new infrastructure is an infrastructure of intelligence.
Wow.
I know that right now, when we say there's an intelligence infrastructure, it makes no sense. But I promise you, in 10 years' time, you will look back and you will realize that AI has now integrated into everything. And in fact, we need AI everywhere.
It's already everywhere.
Every region, every industry, every country,
Oh, okay,
every
that's
company,
not-
all needs AI.
No, it does not.
AI has now part of infrastructure. And this infrastructure, just like the internet, just like electricity, needs factories. And these factories are essentially what we build today. They're not data centers of the past, a $1 trillion industry providing information and storage, supporting all of our ERP systems and our employees. That's a data center of the past. This is similar in the sense that it came from the same industry. It came from all of us, but it's going to emerge as something completely different, completely separated from the world's data center. And these AI data centers, if you will, are improperly described. They are, in fact, AI factories. You apply energy to it, and it produces something incredibly valuable. And these things are called tokens. To the point where companies are starting to talk about how many tokens they produced last quarter and how many tokens they produced last month. Very soon, we'll be talking about how many tokens we produce every hour, just as every single factory does. And so the world has fundamentally changed. We went from a company, on the day that we started our company, I was trying to figure out how big our opportunity was in 1993. And I came to the conclusion, NVIDIA's business opportunity was enormous. $300 million. We're going to be rich. $300 million chip industry to a data center opportunity that represents about $1 trillion to now an AI factory, an AI infrastructure industry that will be measured in trillions of dollars. And this is the exciting future that we're undertaking. Now, at its core, everything we do is founded on several important technologies. Of course, I talk about accelerated computing a great deal. I talk about AI a great deal. What makes NVIDIA really special is the fusion of these capabilities. And very especially, the algorithms, the libraries, what we call the CUDA-X libraries. We're talking about libraries all the time. And in fact, we're the only technology company in the world that talks about libraries nonstop. And the reason for that is because libraries is at the core of everything that we do. Libraries is what started it all. And I'm going to show you a few new ones today. But before I do that, let me show you a preview of what I'm going to tell you today. Everything you're about to see is simulation, science, and artificial intelligence. Nothing you see here is art. It's all simulation. It just happens to be beautiful. Let's take a look.
Oh, physics! Where did it go? Oh, this is the 5090 announcement. The original physics. On 400Z. Oh, that's the neural engine.
This is real-time computer graphics I'm standing in front of. This is not a video, this is computer graphics.
RTX
generated
5060?
by GeForce. This is a brand new GeForce 5060,
What?
RTX 5060. And this
5060
is from ASUS.
laptop.
My good friend Johnny is in the front row.
ASUS.
And this is from MSI.
MSI!
We took this
And put it into
incredible
that.
GPU and we shrunk it in here.
And then
Does
it's
that make
slower.
any sense?
Yes, it does.
See,
It's the laptop
this is
version that's
incredible.
worse.
And so this is MSI's new laptop with 5060 in it. GeForce brought CUDA to the world. Right now, what you're seeing is every single pixel is ray traced. How is that possible? That we're able to
Upscaling
simulate
AI.
photon and deliver this kind of frame rate at this resolution? Well, the reason for that is artificial intelligence.
Yup.
We're only rendering 1 out of 10 pixels. So every pixel that you see, only 1 out of 10 is actually computed. The other 9, AI guessed. Does that make any sense?
Yes, it does.
And it's perfect.
No, it isn't.
It's completely perfect.
No, it
They
isn't.
guessed it perfectly. Of course, the technology is called DLSS, neural rendering. It took us many, many years to develop. We started developing it the moment we started working on AI, so it's been a 10-year journey. And the advance in computer graphics has been completely revolutionized by AI. GeForce brought AI to the world. Now AI came back and revolutionized GeForce. So really, really amazing. Ladies and gentlemen, GeForce. You know, when you're CEO, you have many children. And GeForce brought us here. And now, all of our keynotes is 90% not GeForce. But it's not because we don't love GeForce. GeForce RTX 50 series just had its most successful launch ever, the fastest launch in our history. And PC gaming is now 30 years old. So that tells you something about how incredible GeForce is. Let's talk about libraries. At the core, of course, everything starts with CUDA. And by making CUDA as performant as possible, as pervasive as possible, so that the install base is all over the world, then applications can find a CUDA GPU quite easily. The larger the installed base, the more developers want to create libraries. The more libraries, more amazing things are done, better applications, more benefits to users, they buy more computers. The more computers, more CUDA. That feedback path is vitally important. However, accelerated computing is not general purpose computing. General purpose computing, write software, everybody writes it in, Python or C or C++, and you compile it. The methodology for general purpose computing is consistent throughout. Write the application, compile the application, run it on the CPU. However, that fundamentally doesn't work in accelerated computing, because if you could do that, it would be called a CPU. What's the point of not just changing the CPU so you could write the software, compile the software, run it on a CPU? The fact that you would have to do something different is actually quite sensible. And the reason for that is because so many people worked on general purpose computing, trillions of dollars of innovation. How is it possible that all of a sudden a few widgets inside a chip and all of a sudden computers become 50 times faster, 100 times faster? That makes no sense. And so the logic that we applied is that we could accelerate applications if you understood more about it. You can accelerate applications if you were to create an architecture that are better suited to accelerate, to run at the speed of light, 99% of the runtime, and even though it's only 5% of the code, which is quite surprising. Most applications, small parts of the code consumes most of the runtime. We made that observation, and so we went after one domain after another. I just showed you computer graphics. We also have numerics. This is CuPy numeric. This is CuPy is the most pervasive numerical library. Arial and Shona. Arial is the world's first GPU accelerated radio signal processing for 5G and 6G. Once we make it software defined, then we can put on top of it AI. So now we could bring AI to 5G and 6G. Parabricks for genomics analysis, Mo9 for medical imaging, Earth-2 for weather prediction, cuQuantum for quantum classical computer architectures and computer systems, cuequivariance and cuTensor, contraction of tensor mathematics, Megatron. This whole row, this whole column here consists of all of our deep learning and all of our libraries necessary for training as well as inference for deep learning. This revolutionized computing. And it all started with all these libraries. Not just CUDA, but cuDNN. On top of cuDNN, there was Megatron. Megatron, then TensorRT-LLM, and then now lately, this brand new operating system for large AI factories, Dynamo. cuDF for data frames like Spark and SQL. Structured data can be accelerated as well. cuML, classical machine learning.
Come on.
Or a framework for a Pythonic framework for describing CUDA kernels, incredibly successful. cuOpt, mathematical operations, optimizations, things like traveling salesperson, the ability to optimize highly constrained, large number of variables, type of problems like supply chain optimization. This is an incredible success. I'm very excited about cuOpt, cuDSS and cuSparse for sparse structure simulators. Those are used for CAE and CAD, fluid dynamics, finite element analysis, incredibly important for EDAs and CAE industry. And then, of course, cuLitho, one of the most important libraries for computational lithography. Mask making could easily take a month. And that mask making process is extremely computationally intensive.
No.
Incredibly important. One of them could easily take a month. And that mask making process is extremely computationally intensive. And now with cuLitho, we could accelerate that computation by 50 times, 70 times. As a result, this is going to set the stage, open the world for applying AI to lithography in the future. We have great partners here. TSMC is using cuLitho quite extensively. ASML, Synopsys, excellent partners working with us in cuLitho. So the libraries themselves is what makes it possible for us, one domain of application after another domain of science, after another domain of physics, to be able to accelerate those applications. But it also opens up markets for us. We look at particular regions and particular markets and we say, that area could really be important to transform to the new way of doing computing. if general purpose computing, after all these years, has run its course, why hasn't it run its course in every single industry? So one of the most important industries, of course, is telecommunications. Just as the world's cloud data centers have now become software-defined, it stands to reason that telecommunication should also be software-defined. And so that's the reason why we've taken now some 6 years to refine and optimize a fully accelerated radio access network, RAN stack, that does incredible performance. For data rate per megawatt, or data rate per watt, we are now on par with the state-of-the-art ASICs. And so once we could do that, once we could achieve that level of performance and functionality, then after that we can layer on top AI. And so we have great partners here. You could see SoftBank and T-Mobile, Indosat and Vodafone are doing trials. Nokia, Samsung, Kyocera are working with us on the full stack. Fujitsu and Cisco are working on the systems. And so now we have the ability to introduce the idea of AI on 5G or AI on 6G along with AI on computing. We're doing that with quantum computing. Quantum computing is still at the noisy, intermediate scale quantum, called NISQ. However, there are many, many good applications we could already start to do. And so we're excited about that. We're working on a quantum classical or quantum GPU computing platform. We call it CUDA-Q, working with amazing companies around the world. GPUs could be used for pre-processing and post-processing, for error correction, for control. And so in the future, I predict that all supercomputers will have quantum accelerators, all have quantum QPUs connected to it. And so a supercomputer would be a QPU with QPUs and GPUs and some CPUs. And that would be the representation of a modern computer. So working with a lot of great companies in this area. AI. 12 years ago, we started with perception. AI models that can understand patterns, recognize speech, recognize images. That was the beginning. The last 5 years, we've been talking about generative AI, the ability for AI to not just understand, but to generate. And so it could generate from text to text. We use that all the time in ChatGPT. Text to images, text to video, video to text, images to text. Almost anything to anything, which is the really amazing thing about AI, that we've discovered a universal function approximator, a universal translator. It can translate from anything to anything else if we can simply tokenize it, represent the bits of information. Well, now we have reached a level of AI that's really important. Generative AI gave us one-shot AI. You give it text and it gives you text back. That was 2 years ago when we first engaged ChatGPT. That was the big, amazing breakthrough. You give it text and it gives you text back. It predicts the next word, predicts the next paragraph. However, intelligence is much more than just what you've learned from a lot of data that you've studied. Intelligence.
Sorry, boys, for leaving you.
To reason.
I am genuinely sorry that I didn't read the chat.
That you've not seen before. To break it down step by step. To maybe apply some rules and theorems to solve a problem you've never seen. To be able to simulate multiple options and weigh its benefits. Some of the technology you might have heard about, chain of thought, breaking it down step by step, tree of thought, coming up a whole bunch of paths. All of these technologies are leading the ability for AI to be able to reason. Now, the amazing thing is, once you have the ability to reason and you have the ability to perceive, that is, let's say, multimodal read PDFs.
I just read chat.
You can do search. You can use tools. You have now agentic AI. This agentic AI
I got some fucking cereal
just
milk.
does something that I've just described all of us do. We're given a goal. We break it down step by step. We reason about what to do, what's the best way to do it. We consider its consequences. And then we start executing the plan. The plan might include doing some research, might include doing some work, using some tools. It might include reaching out to another AI agent to collaborate with it. Agentic AI is basically understand, think, and act. Well, understand, think, and act is the robotics loop. Agentic AI is basically a robot in a digital form. These are going to be really important in the coming years. We're seeing enormous progress in this area. The next wave, beyond that, is physical AI. AI that understands the world. They understand things like inertia, friction, cause and effect. That if I roll a ball and it goes under a car, depending on the speed of the ball, it probably went to the other side of the car, but the ball did not disappear. Object permanence. You might be able to reason that if there's a table in front of you and you have to go to the other side, the best way to do it is not to go right through it. The best way is maybe go around it or underneath it. To be able to reason about these physical things is really essential to the next era of AI. We call that physical AI. And so in this particular case, you're seeing us simply prompt the AI, and it generates videos to train a self-driving car in different scenarios, and I'll show you more of that later. That's a dog. It said, generate me a dog, generate me one with a bird, with people. And it started out with the image on the left. And then the phase after that, we take reasoning systems, generative systems, physical AI, and this level of capability would now go into a physical embodiment. We call it a robot. If you could imagine that you can prompt an AI to generate a video to reach and pick up a bottle, of course you could imagine telling a robot to reach out and pick up the bottle. The AI capability today has the ability to do those things. Well, the computer that's where we're going in the near future. The computer that we're building to make this possible has properties that are very different than the previous. The revolutionary computer called Hopper came into the world about 3 years ago, and it revolutionized AI as we know it. It became probably the most popular, most well-known computer in the world. In the last several years, we've been working on a new computer to make it possible for us to do inference time scaling, or basically thinking incredibly fast. Because when you think, you're generating a lot of tokens in your head, if you will. You're generating a lot of thoughts, and you iterate in your brain before you produce the answer. So what used to be one-shot AI is now going to be thinking AI, reasoning AI, inference time scaling AI. And that's going to take a lot more computation. And so we created a new system called Grace Blackwell. Grace Blackwell does several things. It has the ability to scale up. Scale up means to turn what is a computer into a giant computer. Scale out is to take a computer and connect many of them together and let the work be done in many different computers. Scaling out is easy. Scaling up is incredibly hard. Building larger computers that is beyond the limits of semiconductor physics is insanely hard. And that's what Grace Blackwell does. Grace Blackwell broke just about everything. And all of you in the audience, many of you are partnering with us to build Grace Blackwell systems. I'm so happy to say that we're in full production, but we can also say it was incredibly challenging. Although the Blackwell systems based on HGX has been in full production since the end of last year and has been available since February, we are now just putting online all the Grace Blackwell systems. They're coming online all over the place every single day. It's available in CoreWeave now for several weeks. It's already being used by many CSPs. And now you're starting to see it coming up from everywhere. Everybody's starting to tweet out that Grace Blackwell is in full production. In Q3 of this year, just as I promised, every single year, we will increase the performance of our platform.
Here.
Every single year like Rhythm.
Go to YouTube
and this year, in Q3, we'll upgrade to Grace Blackwell GB300. The GB300 will increase it's the same architecture.
Thumbnail.
Same architecture, same physical footprint, same electrical and mechanicals, but the chips inside have been upgraded. It has upgraded with a new Blackwell chip is now 1.5 times more inference performance, has 1.5 times more
Yo guys,
HBM memory,
check the
and it has
thumbnail.
2 times more
In
networking.
about a few seconds, I'll tell you
The
when.
overall system performance is higher. Well, let's take a look at what's inside Grace Blackwell. Grace Blackwell starts with this compute
You can
node.
check the new thumbnail
This
now.
compute node right here, this is one of the compute nodes. This is what the last generation looks like, the B200. This is what B300 looks like. Notice right here in the center, it's 100% liquid cooled now, but otherwise, externally, it's the same. You could plug it into the same systems and same chassis.
Yeah.
So this is the Grace Blackwell GB300 system. It's 1.5 times more inference performance. The training performance is about the same, but the inference performance is 1.5 times more. Now this particular system here is 40 petaflops, which is approximately the performance of the Sierra supercomputer in 2018. The Sierra supercomputer has 18,000 GPUs, Volta GPUs. This one node here replaces that entire supercomputer. 4,000 times increase in performance in 6 years. That
made a
is
new,
extreme Moore's law.
Thumbnail.
Remember, I've said before that AI, NVIDIA has been scaling computing by about 1 million times every 10 years. And we're still on that track. But the way to do that is not just to make the chips faster. There's only a limit to how fast you can make chips and how big you can make chips. In the case of Blackwell, we even connected 2 chips together to make it possible. TSMC worked with us to invent a new CoWoS process called CoWoS-L that made it possible for us to create these giant chips. But still, we want chips way bigger than that. And so we had to create what is called NVLink. This is the world's fastest switch. This NVLink here, right here, is 7.2 terabytes per second. 9 of these go into that rack. And that 9, those 9 switches are connected by this miracle. This is quite heavy. That's because I'm quite strong. I made it look so light, but this is 70 pounds.
Cap.
And so this is the NVLink spine. 2 miles of cables, 5,000 cables structured, all coaxed, impedance matched, and it connects all 72 GPUs to all of the other 72 GPUs across this network called NVLink switch. 130 terabytes per second of bandwidth across the NVLink spine. So just put in perspective, the peak traffic of the entire internet, is 900 terabits per second. Divide that by 8. This moves more traffic than the entire internet
combined.
1 NVLink spine across this 9 of these NVLink switches, so that every single GPU can talk to every other GPU
It does
at
look
exactly
nice,
the same time. This is the miracle of GB200. And because there's a limit to how far you can drive SerDes, this is as far as any SerDes has ever driven. From chip, this goes chip to the switch, out to the spine, to any other switch, any other chip, all electrical. And so that limit caused us to put everything in one rack. And that one rack is 120 kilowatts, which is the reason why everything has to be liquid cooled. We now have the ability to disaggregate the GPUs out of one motherboard, essentially, across an entire rack. And so that entire rack is one motherboard. That's the miracle. Completely disaggregated, and now the GPU performance is incredible, the amount of memory is incredible, the networking bandwidth is incredible, and now we can really scale these out. Once we scale it up, then we can scale it out into large systems. And notice almost everything NVIDIA builds are gigantic. And the reason for that is because we're not building data centers and servers, we're building AI factories. This is CoreWeave. This is Oracle Cloud. The power density of each rack is so great. They have to put them further apart so that the power density could be distributed. But really, in the end, we're not building data centers, we're building AI factories. And this is the XAI, Colossus factory. This is Stargate. 4 million square feet. 4 million square feet, 1 gigawatt. And so just think about this factory here. This 1 gigawatt factory, is probably going to be about, 60 to 80 billion dollars. Out of that 60 to 80 billion dollars, the electronics, the computing part of it, these systems are 40, 50 billion dollars of it. And so these are gigantic factory investments. The reason why people build factories
about 3
is because
centimeters per wire, or 3
3
meters per wire.
You know the answer.
Average.
The more you buy.
Oh. The more you save. No. No.
Say it with me. The more you buy, the more you make.
Oh.
That's what factories do. Okay.
Yep.
The technology is so complicated. And in fact, just looking at it here, you still cannot get the deep appreciation of the amazing work that's being done in all of our partners and all of the companies here in the audience in Taiwan. And so we made you a movie. I made you a movie. Take a look.
Let's see this. Let's see this movie. Oh, this is
Blackwell
the wafer.
Is an engineering marvel. It begins as a blank silicon wafer at TSMC. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer on a 12-inch wafer. The wafer is scribed into individual Blackwell die, tested
how can
and
I make
sorted,
it
separating the good dies to move forward. The
Can I
chip on
start
wafer on substrate process, done at TSMC, SPIL, and Amkor, attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system and package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the Blackwell B200 superchip. At KYEC, each Blackwell is stress tested in ovens at 125 degrees Celsius and pushed to its limits for several hours. Back at Foxconn, robots work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. Meanwhile, additional components are being prepared at factories across the globe. Custom liquid cooling copper blocks from Cooler Master, AVC, Auras, and Delta keep the chips at optimal temperatures. At another Foxconn facility, ConnectX-7 SuperNICs are built to enable scale-out communications, and Bluefield 3 DPUs to offload and accelerate networking, storage, and security tasks. All these parts converge to be carefully integrated into GB200 compute trays. NVLink is the breakthrough high-speed link that NVIDIA invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom line-mated backplane, integrating 5,000 copper cables to deliver 130 terabytes per second of all-to-all bandwidth.
And wreak havoc upon my chat.
This connects
that
all
would be kind of
72
cool.
Blackwells
I can give the permission to
144
anyone.
GPU dies into one giant GPU. From around the world, parts arrive.
You know what?
From Foxconn, Wistron, Quanta, Dell, Asus, Gigabyte,
guy.
HPE, Supermicro,
Add as
and other
moderator.
partners to be assembled by skilled technicians into a
Yeah, there we go.
rack-scale AI supercomputer.
The person
In
that is
total,
has the initials
1.2 million
YG
components,
is now a
2
moderator
miles
in
of
my
copper
channel.
cable, 130
If they really
trillion
want to be.
transistors, weighing 1,800 kilograms. From the first transistor etched into a wafer to the last bolt fastening the Blackwell rack, every step carries the weight of our partners' dedication, precision, and craft. Blackwell is more than a technological wonder. It's a testament to the marvel of the Taiwan technology ecosystem.
Wait, Intel? Really?
We
Kyoxian?
couldn't be prouder
SanDisk Sams? Oh, SanDisk got a remake. Okay,
of what we've
Micron.
achieved together.
Infineon. Texas Instruments. That's the one I know. Molex is a company? Cooler Master, BYOD.
Thank you, Taiwan.
BOYD. Let's
Thank
see,
you.
Jensen.
Thank
Leatherman
you.
jacket.
That was pretty incredible, right? But that was you. That was you.
Yippee!
Thank you.
You give me money, and I give you products. That is sometimes
Well,
good.
Taiwan doesn't just build supercomputers for the world. Today, I'm very happy to announce that we're also building AI in
No!
Taiwan.
No
So today
fucking
we're
way,
announcing
bro.
That Foxconn, Taiwan, the Taiwanese government, NVIDIA, TSMC, we're going
Wow.
to build the first giant AI supercomputer
Wow.
here for the AI infrastructure and the AI ecosystem of Taiwan. Thank you.
Yippee! AI infrastructure. Let's go, boys.
Is there anybody who needs an AI computer?
No. Nobody. Literally nobody!
Any AI researchers in the audience?
Nope. A few.
Every single student, every researcher, every
No.
scientist, every
No.
startup,
Nope.
every large established company,
You do not need it.
TSMC themselves does enormous amounts of AI and scientific
yeah.
research already. And so Foxconn does an enormous amount of work in robotics. I know that there are many other companies in the audience, I'm going to mention you in just a second, that are doing robotics research and AI research. And so having a world-class AI infrastructure here in Taiwan is really important. All of that is so that we could build a very large chip. And NVLink and Blackwell, this generation, made it possible for us to create these incredible systems. Here's one from Pegatron and QCT
person
and
left.
Wistron and WeWin. This is from Foxconn and Gigabyte and Asus. And you could see the front and the back of it. And its entire goal is to take these Blackwell chips that are, you know, you could see how big they are, and turn it into one massive chip. Now, the ability to do that, of course, was made possible by NVLink. But it understates the complexity of the system architecture, the rich software ecosystem that connects it all together, the entire ecosystem of 150 companies that came together to build this. This architecture and the entire ecosystem in technology, in software, in industry has been the work of 3 years. This
I
is a
updated the
massive
live stream
industrial
title
investment.
to keep you hooked.
And now
Let's see.
we would like to make it possible for anybody who wants to
Oi.
build data centers.
There we go.
It could be a whole bunch of NVIDIA GB200s or 300s and accelerated computing systems from NVIDIA. It could be somebody else. And so today, we're announcing something very special.
Okay.
We're announcing NVIDIA NVLink Fusion. NVLink Fusion is so that you can build semi-custom AI infrastructure. not just semi-custom chips, because those are the good old days. You want to build AI infrastructure, and everybody's AI infrastructure could be a little different. Some of you could have a lot more CPUs, and some of it could have a lot more NVIDIA GPUs, and some of it could be somebody's semi-custom ASICs. And those systems are so insanely hard to build. And they're all missing this one incredible ingredient.
You need 500.
This incredible ingredient called NVLink.
Oh, community.
NVLink, so
I
that
need
you can
500
scale
subs.
up
Unfortunate.
these semi-custom systems and build really powerful computers.
You
And
can't
so today
make
we're
a...
announcing the NVLink Fusion. NVLink Fusion kind of works like this.
Bulls.
This is the NVIDIA platform, 100% NVIDIA. You got NVIDIA CPU, NVIDIA GPU, the NVLink switches,
All right.
the networking
Who's in the
from
chat?
NVIDIA
Reveal
called
yourself.
Spectrum X or InfiniBand,
Because I can see there's
Next.
3 people.
network interconnects, switches,
Type
And
yes
all
in
of
the
the
chat
entire
if you want
system,
me to face reveal.
the entire infrastructure built end to end. Now, of course, you can mix and match it if you like. And we now today make it possible for you to mix and match it even at the compute level. This would be
Oh,
what you would
they're
do
all left.
using
left.
your custom ASIC.
Unfortunate.
And we have great partners I'll announce in a second who are working with us to integrate your special TPU or your special ASIC, your special accelerator. And it doesn't have to be just
What
a
the-
transformer accelerator. It could be an accelerator of any kind that you would like to integrate into a large scale-up system.
Wait,
We
what?
create an NVLink chiplet. It's basically a switch that abuts right up to your chip. There's IP that will be available
Oh, new
to integrate
person.
into your semi-custom ASIC.
Hello.
And
Hello,
then
viewer.
once you do that, it fits right into the compute boards that I mentioned, and it fits into this
I'm looking at the
ecosystem of an AI
248
supercomputer that I
reactions.
showed
Oh,
you.
that's me.
Now
You
maybe
could just spam them.
what you would like is you would like to use your own CPU.
Let's
You've been
see.
building your own CPU for some time,
Oh
and
my.
maybe your CPU has built a very large ecosystem, and
Let's
you would like
see.
to
Will it
integrate
update?
NVIDIA into your ecosystem. And now we can make it possible for you to do that. You could do that by building your custom CPU. We provide you with our NVLink chip-to-chip
Uh-oh.
interface into your ASIC. We connect it with NVLink chiplets, and now it connects and directly abuts into the Blackwell chips and our next generation Rubin chips. And again, it fits right into this ecosystem. This incredible body of work now becomes flexible and open for everybody to integrate into.
Okay.
And so your AI infrastructure could have some NVIDIA, a lot of yours. A lot of yours, you know, and a lot of CPUs, a lot of ASICs, maybe a lot of NVIDIA GPUs as well. And so in any
And
case,
gone.
you have the benefit of
They're
using
gone.
the NVLink infrastructure and the NVLink ecosystem, and it's connected perfectly to Spectrum X. And all of that, you know, is industrial strength and has the benefit of an enormous ecosystem of industrial partners who have already made it possible.
Oh.
So this is the NVLink Fusion.
To
Whether you
54
buy
what?
completely from us, that's fantastic. Nothing gives me more joy than when you buy everything from NVIDIA. I just
Hello?
want you guys to know that. But
Okay.
it gives me tremendous joy if you just buy something from NVIDIA.
Да. Ні, це хлопці. Дякую, мам.
So we have some great partners. We have some great partners.
Okay.
L-Chip, Astera
Добре.
Labs, Marvell, and one of our great partners,
You know what?
MediaTek, are going to be partnering with us to work
Might
with
pause
ASIC
this
or
stream and just
semi-custom
start playing
customers
Forza Horizon 4.
who would like to build
'Cause
these things, or
this is
CPU
boring
vendors
as
who would
hell.
like to
You
build
guys
these things,
agree?
And they would be their semi-custom ASIC provider. We also have Fujitsu and Qualcomm who are building their CPUs with NVLink
Wait.
to integrate into our ecosystem. And Cadence and Synopsys, we've worked with them to
Can you guys hear
transfer
me?
our IP to them
Is
so
it-
that they
is it
can work with
okay?
all of you and make that IP available to all of your chips. So this ecosystem is incredible, but this just highlights the NVLink Fusion ecosystem. Once you work with them, you instantly get integrated into the entire larger NVIDIA ecosystem.
Yeah, this is boring.
For you to scale up into these AI supercomputers.
I'll rename the stream
Now let me talk to you about some
and
new
then
product categories.
remove the thumbnail
As you know,
and do something
I've
else.
shown you a couple of different computers. However, in order to serve the vast majority of the world, there are still some computers
Should I
that
just
are missing.
live stream chess?
And so I'm going to talk about them.
Probably
But
not.
before I do that, I want to give you an update that in fact, this new computer we call DGX Spark
Chillin.
is in full production. DGX Spark
Save that.
will be ready, will be available shortly, probably in a few weeks. We have tremendous partners working with us. Dell, HPI, ASUS, MSI, Gigabyte,
Oh, you can't remove thumbnails?
Lenovo. Incredible partners working with us. And this is the DGX Spark. This is actually a production unit. This is our version. This is our version. However, our partners are building a whole bunch of different versions.
Fun fact, I sent a message
This
to
is
Jensen
designed
Huang.
for
through
AI
you.
native developers.
I sent a message to Jensen Huang to rename this thing to Minix, and he declined. He didn't reply to me at all. Unfortunate, but he has better things to do. So that's a bit of lore on me.
If you're a developer, you're a student, you're a researcher, and you don't want to keep opening up the cloud and getting it prepared, and then when you're done scrubbing it, okay, but you would just like to have your own, basically your own AI cloud sitting right next to you, and it's always on, always waiting for you. It allows you to do your prototyping, early development, and this is what's amazing. This is DGX Spark. It's 1 petaflops and 128 gigabytes. In 2016, when I delivered DGX1, this is just the bezel. I can't lift the whole computer. It's 300 pounds. This is DGX1. This is 1 petaflops and 128 gigabytes. Of course, this is 128 gigabytes of HBM memory. And this is 128 gigabytes of LPDDR5X. The performance is in fact quite similar. But what's most important is that the work that you could work on this is the same work you could do here. It's an incredible achievement over just the course of about 10 years. So this is
that's what it
DGX
is.
Spark for anybody who would like to have their own AI supercomputer. And it's, I'll let all of our partners price it for themselves.
Oh,
But
that's a free-for-all, dude.
one thing
That's
for
a
sure,
free-for-all.
everybody can have one for Christmas.
I will... If you're watching this, Jensen Huang, could you
Okay,
please
I've got
give me
another
one?
computer I want to show you.
Nah, probably
that's
not.
not-
He,
if
he'll
that's
not
not
see
enough-
this. I have like 3 viewers. Come on, man.
And you would still like to have your own personal. Thank you, Janine. This is Janine Paul, ladies and gentlemen.
Janine Paul. Who is this Janine Paul
If that
person?
one isn't big enough for you, here's one. This is another
Dude, that
desk
silicon is
side.
massive,
This is
though.
also going to be available from Dell and HPI, ASUS, Gigabyte, MSI, Lenovo. It'll be available from Box, from Lambda, amazing
Lambda?
workstation companies. And this is going to be your own personal DGX supercomputer.
Alright.
This computer is the most performance you can possibly get out of a wall socket. You could put this in your kitchen,
That's a
but
very
just
weird.
barely.
Just
If you put this in your kitchen and then somebody runs the microwave, I think that's the limit. And so this is the
Okay.
limit. This is the limit of what you can get out of a wall outlet.
Wait,
And
this is
a
just a
DGX
typical.
station. The programming model of this and the giant systems that I showed you are
There's
the
no
same.
cooling.
That's the amazing thing. One architecture, and this has the ability, enough capacity and performance to run a 1 trillion parameter AI model.
Impressive.
Llama
But
is
does it
Llama
get
70B. A 1 trillion parameter model is going to run wonderfully on this machine. Okay, so that's the DGX station.
All right.
So now let's talk about. Remember, these systems are. Thank you.
I'm
Jim.
gonna remove
These
the
systems.
the
These
cringy
systems are
clickbait.
AI natives. They're AI native computers. They're computers built for this new generation of software.
There.
It doesn't have to be x86 compatible.
Removed it.
It doesn't have to run traditional IT software.
How long
It
are we
doesn't
live
have to
for?
run hypervisors. It doesn't
Let me
have to
check
run all
real
of the.
quick.
It doesn't have to run Windows. These
Okay, can't
computers are
tell.
designed for the modern AI native applications. Of course, these AI applications could be APIs that can be called upon by the traditional and the classical applications. But in order for us to bring AI
Average one.
into a new world, and this new world is enterprise IT.
Copyright. No
We have to go back to our roots, and we have to reinvent computing and bring AI into traditional enterprise computing. Now, enterprise computing, as we know, is really three layers. It's not just the computing layer. It's compute, storage, and networking. It's always compute, storage, and networking. And just as AI has changed everything, it stands to reason that AI must have changed compute, storage, and networking for enterprise IT as well. Well, that lower layer has to be completely reinvented, and we're in the process of doing that. I'm going to show you some new products that opens up, unlocks enterprise IT for us. It has to work with the traditional IT industry, and it has to add a new capability. And the new capability for enterprise is agentic AI. Basically, digital marketing campaign manager, a digital researcher, a digital software engineer, digital customer service, digital chip designer, digital supply chain manager, digital versions, AI versions of all of the work that we used to do. And as I mentioned earlier, agentic AI has the ability to reason, use tools, work with other AIs. So in a lot of ways, these are digital workers. They're digital employees. The world has a shortage of labor. We have a shortage of workers. By 2030, by about 30 to 50 million shortage. It's actually limiting the world's ability to grow. And so now we have these digital agents that can work with us. 100% of NVIDIA software engineers now have digital agents working with them so that they can help them, assist them in developing better code and more productively. And so in the future, you're going to have this layer. That's our vision.
Nobody's here. I'm just watching a person explain shit. Clearly nobody's in the chat. Not because I have a viewer incentive to live stream, but you came for what you wanted, which was me, but what I started to stream for was to see what the 5060 was about. So let me try to find that, because I was there when he just unveiled it, perhaps around here, where he was like, oh, it could fit in here. So I'm gonna go back there. Where is this? Okay. I gotta find where he introduced the 5060. Is this the 5060? No, this is the scientific data computers where he keeps on rambling. Yeah, this is the rambling part. I need to find where he did the 5060 stuff, because that's what I wanted to know about. Did he say anything past the we fit a 5060 inside a laptop? Oh, there he is.
And so this is MSI's new
MSI's
laptop
new
with 5060 in it. Right now, how is that? The other 9.
The other 9 are guests. I get it.
Ladies and gentlemen, GeForce.
Yeah. Is that it?
Of our keynote.
Bro, that's
now
it?
30 years old.
Really?
So that tells you.
He didn't show any graphs. He didn't say anything. And he just talked about AI. And all of his AI bullshit. This entire time. I'm disappointed. Oh. RTX A6000s, those are each like 10 grand. That's horrible. Wow. Clap, clap, clap.
Okay.
Woo! Horrible. Capitalism at its finest. Oh, Azrock.
Brand new RTX Pro.
A6000.
RTX Pro Enterprise and Omniverse server.
Okay.
This server can run everything.
I doubt that.
Of course. It can run all of the classical hypervisors. It runs Kubernetes in those hypervisors.
What the fuck does that mean?
The way that your IT department wants to manage your network and how they want to manage your clusters and orchestrate workload works exactly the same way.
That just sounds like
to even stream Citrix and what other what other virtual desktops to your PC. Everything that runs in the world today should run here. Omniverse runs on here perfectly. In addition to that, this is the computer for enterprise AI agents. Those AI agents could be only text. Those AI agents could also be computer graphics.
Wow.
Little TJs, you know, coming to you. Little Toy Jensen's coming to see you.
Toy Jensen's. He has a fucking slogan.
Those AI agents could be either in text form,
Chinese.
it could be in graphics form, it could be in video form.
Chinese.
All of those workloads work on this system. No matter the modality, every single model that we know of.
It would be kind of funny if Jensen were to be bombed. Not that I wanted to die, but it would be kind of interesting if China were to launch an attack right about now on Taiwan, because Taiwan is a pretty small country. Oh no, Taiwan country. I'm gonna get silenced by the Chinese.
Okay, what connects these 8 GPUs, the new Blackwell RTX Pro 6000s?
Oh,
this new motherboard.
I guessed it.
This new motherboard is actually a switched network.
Ah.
CX8 is a new category of chips.
Okay.
It's a switch first, networking chip second. It's also the most advanced networking chip in the world.
All right.
This is now in volume production, CX8. In the CX8, you plug in the GPUs. The CX8s are in the back. PCI Express connected here. CX8 communicates between them. And the networking bandwidth is incredibly high at 800 gigabits per second. And this is the transceiver.
That's a really nice looking Ethernet cable.
So each one of these GPUs have their own networking interface.
All
of the GPUs are now.
I gotta love how he's just handling that like it's not a prototype. Like it's just, yeah, we just have these.
Communicating to all.
This is probably worth more than I've ever spent in my life, and he's just casually just beside 2 of them.
All of the other GPUs on east-west traffic.
Alright.
Incredible performance. Now,
Incredible performance. I do not give a fuck here. Can you please get to the 5060?
This is the performance, and I showed you guys GTC, how to think about performance in the world of AI factories.
AI factories.
The way to think about this is throughput. This is tokens per second.
What the fuck does this say? What does this mean? Tokens per second per $5 million. This is only to investors. This graph. For me, this could be like how many times I ship per day. Or how many times I piss per day during the hours. And this is like 4 hours in, 8 hours in, 12 hours in, 16 hours in. And then this is me fucking snoring my shit. This doesn't make sense to me. Jensen has explained absolutely fuck all. I would like someone to explain to me, at least in the chat. Bruh, try Sky saying boring. Okay, I would like Jensen to explain what the fuck is he talking about.
Just the y-axis. The more output your factory, the more tokens you produce. Okay, so throughput is measuring tokens per second. However, every AI model is not the same. And some AI models require much more reasoning. And so you need those AI models, you need the performance per user to be very high. So the tokens per second per user has to be high. And this is the problem with factories. Factories either like to have high throughput or low latency, but it doesn't like to have both. And so the challenge is how to create an operating system that allows us to have high throughput, the y-axis, while having very low latency, which is the y-axis, interactivity, tokens per second per user.
You just said y-axis twice.
Tells you something about the overall performance of the computer, of the overall computer of the factory. Look at all those different colors. It represents the different ways you have to configure all of.
Okay, so this is kind of like the same with series and parallel. So, series and parallel. Let's go Wikipedia. Series and parallel circuits. So, what series looks like, where is it? Series and parallel. I think this is parallel, yes. Parallel gives you more life, but same voltage. And series connects this point to this point and this point to this point. No, this point to this point. Or, yeah, positive to negative and then negative to positive. This would give you twice the power but the same battery life. So, my thing with AI here is why don't you just get 4 of them, put 2 in series, and 2 in parallel, like 2 groups of 2, series parallel.
Across all of our partners in the industry. This is likely the largest go-to market of any system we have ever taken to market. So thank you very much.
Wow.
The compute platform is different. The storage platform is different. And the reason for that is because humans query structured databases like SQL. People query structured databases like SQL. But AI wants to query unstructured data. They want semantic, they want meaning. And so we have to create a new type of storage platform. And this is the NVIDIA AI data platform.
All right.
On top, just as SQL servers, SQL software, and file storage software from your storage vendors that you work with, there's a layer of very complicated software that goes with storage. Most storage companies, as you know, is mostly a software company. That software layer is incredibly complicated. And so on top of a new type of storage system is going to be a new query system.
Oh, please. No, don't die on us.
NVIDIA AIQ or IQ. And this, it's really state-of-the-art. It's fantastic. And working with basically everybody in the storage industry. Your future storage is no longer CPUs sitting on top of a rack of storage. Let me guess. It's AI chips mashed together, having sharing a motherboard with a power supply. It's going to be GPUs sitting on top of a rack of storage. And the reason for pretty much what I said, but not that is because you need the system to embed, find the meaning in the data, in the unstructured data, in the raw data. Find the meaning in life, Jensen. Why don't you tell me what the meaning of life is? To index, you have to do the search and you have to do ranking. So that process is actually, I want to see. Chat GPT. Oh, go back. What is the meaning of life? Tell me. Meaning of life. Oldest and most profound questions. Okay. Philosophical perspective. No intent, meaning each person to create their own. Like Camus, conflict between search for meaning, universes, the absurd. Trans to maximize happiness or reduce suffering. Spiritual law. Christianity, often knowing and serving God. Buddhism sees life as a cycle, suffering. So this was just a bunch of bullshit. Okay, let's go back. And so most storage servers in the future will have a GPU computing node in front of it. It's based on the models that we create. Almost everything that I'm about to show you starts with great AI models. We create AI models. We put a lot of energy and technology into post-training of open AI models. We post-train these AI models. Open AI models. Completely transparent to you. It is safe and secure data, and it's completely okay to use to train, and we make that list available to you to see. And so it's completely transparent. We make the data available to you. We post-train the models, and our post-trained model performance is really incredible. It's right now downloadable open source reasoning model. The Llama Nemotron reasoning model is the world's best. It's been downloaded tremendously. It's been also. Why don't they make it more open source? Because if you search up is open AI open source, it'll say it's considering a different open source strategy. It was recently announced to release an open weight AI models, which means the weights of the model will be publicly available, but the training data and specific model architectures will still be kept private. They're saying, it's going to be open source. No, they're just lying to your face. OpenAI is not open. And they're saying Jensen Huang is lying to people's faces in front of 18,584 people. We also surround it with a whole bunch of other AI models so that you can do what is called IQ, the retrieval part of it. It's 15 times faster than what's available out there, 50% better query results. And so these models are all available to you. Its blueprints the IQ blueprint are open source. And we work with the storage industry to integrate these models into their storage stack, their AI platform. This is VAST. This is what it looks like. I'm not going to go into it. I just want to give you a texture of the AI models that are integrated into their platform. Let's take a look at what VAST has done.
Agentic AI changes how businesses use data to make decisions. In just 3 days, VAST built a sales research AI agent using the NVIDIA IQ blueprint and its accelerated AI data platform. Using Nemo Retriever, the platform continuously extracts, embeds, and indexes data for fast semantic search. First, the agent drafts an outline. Then, taps into CRM systems, multimodal knowledge bases, and internal tools. Finally, it uses Llama Nemotron to turn that outline into a step-by-step sales plan. Sales planning that took days now starts with an AI prompt and ends with a plan in minutes. With Vast's accelerated AI data platform, organizations can create specialized agents for every employee.
Okay, so that's Vast. Dell has a great AI platform, one of the world's leading storage vendors. Hitachi has a great AI platform, AI data platform. IBM is building an AI data platform with NVIDIA NeMo. NetApp is building an AI platform. As you can see, all of these are open to you, and if you're building an AI platform with a semantic query AI in front of it, NVIDIA NeMo is the world's best. Okay, so that gives you now compute for enterprise and storage for enterprise. The next part is a new layer of software called AI Ops. Just as supply chain has their ops and HR has their ops, in the future, IT will have AI Ops. And they will curate data, they'll fine-tune the models, they'll evaluate the models, guardrail the models, secure the models, and we have a whole bunch of libraries of models necessary to integrate into the AI Ops ecosystem. We've got great partners to help us do that, to take it to market for us. CrowdStrike is working with us. Data IQ is working with us. Data Robots is working with us. You can see these are all AI operations creating fine-tuning models and deploying models for agentic AI in enterprise. And you can see NVIDIA libraries of models integrated all over it. So Data Robots, here's Data Stacks. This is Elastic. I think I heard somewhere that they're downloaded 400 billion times. This is Nutanix.
Oh. This is dying again. There's
Is
nothing to
Red Hat.
talk about. Come on.
This is Trend Micro here in Taiwan.
Uh-huh.
I saw Eva earlier. Okay, hi Eva. Okay,
Who the fuck is Eva?
weights and biases. Okay, and so that's it. This is how we're going to bring the world and bring to the world's enterprise IT the ability to add AI to everything that you do. You're not going to rip out everything from IT, the enterprise IT organizations, because companies have to run. But we can add AI into it. And now we have systems that are enterprise ready with ecosystem partners, incredible ecosystem partners. I think I saw Jeff earlier. There's Jeff Clark, the great Jeff Clark, been coming to
Okay.
Taiwan for as long as I have been coming to Taiwan. It's been a partner of all yours for a long time. So there's Jeff Clark. And so our ecosystem partners, Dell and others, are going to take this platform, these platforms, to the world's enterprise IT. Okay, let's talk about robots. So agentic AIs, AI agents, a lot of different ways to say it, agents are essentially digital robots. Reason for that is because a robot perceives, understands, and learns. And that's essentially what agents do. But we would like to build also physical robots.
Okay.
And these physical robots, first, it starts with the ability to learn to be a robot.
Mark Zuckerberg. He's Mark Zuckerberg. We now know that he is now Mark Zuck. He's now this guy. And there's this Mark Zuckerberg meme. Zuckerberg AI chart. Images. Or... No. There's like this meme. Where is it? Mark Zuckerberg AI. No. Mark Zuckerberg. What is it? Mark Zuckerberg comparison. No. Comparison. I guess it's... Gotta search up the word. No. Commenting on Mark Zuckerberg as a lizard. Oh, where is it? Anyway. I remember somewhere there was Mark Zuckerberg's human-like characteristics with AI advancements of how human it was, and it was like a direct correlation, and it was a nonsensical can you finish it up? What do you mean by that? Unpog.
The ability to learn to be a robot can't be done in the physical world productively. You have to create a virtual world where the robot can learn how to be a good robot. That virtual world has to obey the laws of physics. Most physics engines don't have the ability to, with fidelity, deal with rigid and soft body simulation. And so we partner with DeepMind, Google DeepMind, and Disney Research to build Newton, the world's most advanced physics engine. It's going to be open sourced in July. It's incredible what it can do. It's completely GPU accelerated. It's differentiable, so you could learn from experience. It is incredibly high fidelity. It's super real time. And so we could use that Newton engine, and it's integrated into Mujoko. It's integrated into NVIDIA's Isaac Sim, so irrespective of the simulation environment and framework you use. And so with that, we can bring these robots to life.
All right. Oh, this is a Disney robot. My beast came out? What do you mean by that? Alright. 2D2. No comment.
Who doesn't want that? I want that. Can you imagine one of those little ones or a few of them running around the house, chasing your dogs, driving them crazy? And so, did you see what was happening? It wasn't an animation, it was a simulation.
Wow.
And he was slipping and sliding in the sand, in the dirt. All of it was simulated. The software of the robot is running in the simulation. And so it wasn't animated, it was simulated. And so in the future, we'll take the AI models that we train and we put it into
I do play Valorant
in simulation and let it learn how to be a great robot. Well, we're working on several things to help the robotics.
Get to the point. Put the fries in the back.
Has 3 systems. Here, we're deploying Mercedes around the world, our self-driving car stack, end-to-end stack. But we create all of this.
Oh, self-driving cars, we gotta lock in.
The same that we work everywhere else. We create the entire stack, whatever they want to use. Runtime, however much you would like to use, it's up to you. Because there's a lot of different engineering teams and different engineering styles and different engineering capabilities. We want to make sure that we provide our technology in a way that makes it as easy as possible for everybody to integrate NVIDIA's technology.
Are we gonna die because of AI?
I love it if you buy it.
My opinion, we're probably not gonna die because of AI, but I feel like it's gonna be one of the contributing factors.
Everything from me, but just please buy something from me.
Probably some like malfunction because there was ChatGPT 2 incident. The true story of how ChatGPT 2 became maximally lewd. This could be with like ChatGPT 8. ChatGPT 8 or something like that. Being, there's like a mismatch in code considering humans is safe, and then as immediate threats that you have to kill immediately, and then you get shot by an AI.
Very practical. And so we're doing exactly the same thing in robotic systems, just like cars. And so this is our Isaac Groot platform. The simulation is exactly the same as Omniverse. The training system is the same. When you're done with the model, you put it inside this Isaac Groot platform. An Isaac Groot platform starts with a brand new...
ChatGPT 2 looks hot. I think I know you, Squeaker. Yeah, you're the type of person. Wait, didn't you comment on my barrel video? Wait. YouTube Studio. Wait. Let's expose this man in 4K. Let's go. No, it's not made for kids. Save. Let's go to comments. Ah. Was it? Nope. It wasn't him. Okay. He's clean.
Computer called Jetson Thor. This is just started in production. It is an incredible processor. Basically, a robotic processor.
You deleted it right now? Oh, maybe. Who knows?
Driving cars.
I don't really care. It was the 4K video. let's see. Driving in 4K, subtitles, comments. I haven't responded. Oh, that's not 4K. It was. Look. Here. It's... Okay. To be honest, I will admit it wasn't 4K technically, but I rendered it using 4K. But I did record on 1440p, so most of the 4K, it was there. It wasn't like a 1080p video, because, you know, resolution, visual. Because if you take a look, that's 1080p here. Cause full HD, and then this is 4K. Meanwhile, 1440p to 4K is a lot less. Or no, this 4K. Yeah. 1440p and then 1080p. So it was like, it was closer to 4K than 1080p.
And it goes into a human or robotic system. On top is an operating system we call NVIDIA Isaac. The NVIDIA Isaac operating system is the runtime. It does all of the neural network processing, the sensor processing, pipelines all of it, and deliver actuated results. And then on top of it, pre-trained models that we created with an amazing robotics team that are pre-training these models. And all the tools necessary in creating this, we make available, including the model. And so today we're announcing that Isaac Group N1.5 is now the human demonstration systems. And so this is essentially going from real to
I'm
real,
not gonna leak my
AI
age.
to help us expand, amplify the amount of data that was collected during human demonstration to train an AI model. Let's take a look.
The age of generalist robotics has arrived, with breakthroughs in mechatronics, physical AI, and embedded computing. Just in time, as labor shortages limit worldwide industrial growth. A major challenge for robot makers is the lack of
Squeaker
real,
wants
synthetic data to train them. Human demonstrations aren't scalable, limited by the number of hours in a day. Developers can use NVIDIA Cosmos Physical AI World Foundation models to amplify data. Groot Dreams is a blueprint built on Cosmos.
Yo, quick question. Do any of you play CS? Like, play CS2? Kinda wanna play a bit of CS2. After that, I do. Alex, who the fuck are you? I have never... I'm 21. I do 6 on it. What the fuck?
Cosmos for large-scale synthetic trajectory data generation, a reel-to-reel data workflow. First, developers fine-tune Cosmos with human demonstrations recorded by teleoperation of a single task in a single environment. Then, they prompt the model with
whoa,
an image and
whoa.
time. Generalist.
Go back.
Human demonstrations aren't
Rewind that.
limited by the number of hours in a day. Developers can use NVIDIA Cosmos Physical AI World Foundation models to amplify data. Groot Dreams is a blue.
Imagine working at like an AI company, and all you do is just like hand movements of picking up random shit and looking at it and then placing it somewhere else.
Blueprint built on Cosmos for large-scale synthetic trajectory data generation, a reel-to-reel data workflow. First, developers fine-tune Cosmos with human demonstrations recorded by teleoperation.
Oh, that's a glove. I thought the guy had prosthetics on both hands.
Of a single task in a single environment. Then, they prompt the model with an image and new instructions to generate dreams, or future world states. Cosmos is a generative model, so developers can prompt using new action words without having to capture new teleop data. Once a large number are generated, Cosmos reasons and evaluates the quality of each dream, selecting the best for training. But these dreams are still just pixels. Robots learn from actions. The Groot Dreams blueprint generates 3D action trajectories from the 2D dream videos. This is then used to train the robot model. Groot Dreams lets robots learn a huge variety of new actions with minimal manual captures, so a small team of human demonstrators can now do the work of thousands. Groot Dreams brings developers another step closer to solving the robot data challenge.
That sanding job, though.
Is that correct? Far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But human or robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers enormous. But this is one of those applications that needs 3 computers. One computer is an AI for learning. One computer is a simulation engine where the AI can learn how to be a robot in a virtual environment. And then also the deployment of it. Everything that moves will be robotic. As we put these robots into the factories, remember, the factories are also robotic. Today's factories are so incredibly complex. This is Delta's manufacturing line, and they're getting it ready for a robotic future. It is already robotic and software defined, and now in the future there'll be robots working in it. Robotic, digital. Spins. They're all simulations. They just look beautiful. This is Foxconn's digital twin. This is.
Oh.
Look.
Oh. Oh. Okay.
This is Gigabyte's digital twin of plants being planned around the world. Over the next 3 years,
why are you watching this?
$5 trillion of new plants. Because the world is.
Alex, it was because if you read the title of the live stream, just maybe, you might just maybe realize why. Just maybe. Why the RTX? Because that's the name of the graphics card.
Reshaping, because reindustrialization moving around the world.
Also, RTX the RT in RTX is ray tracing.
New plants are.
It's simulating the sun, it's simulating light rays, the same way that humans would see them.
Being built everywhere. This is an enormous opportunity for us to make sure that they build it well and cost effectively and on time. And so putting everything into a digital twin is really a great first step and preparing it for a robotic future. In fact, building that $5 trillion doesn't include a new type of factory that we're building. And even our own factories, we put in a digital twin. This is the NVIDIA AI factory in a digital twin. Kaohsiung is a digital twin. They made Kaohsiung a digital twin. There are already hundreds of thousands of buildings, millions of miles of roads. And so, yes, Kaohsiung is a digital twin. Let's take a look at all of this.
Taiwan is pioneering software-defined manufacturing. TSMC, Foxconn, Wistron, Pegatron, Delta Electronics, Quanta, WeWin, and Gigabyte are developing digital twins on NVIDIA Omniverse for every step of the manufacturing process. TSMC with MedAI generate 3D layouts of an entire fab from 2D CAD and develop AI tools on QOP that can simulate and optimize intricate piping systems across multiple floors, saving months of time. Quanta, Wistron plan multi-step processes.
Okay.
Fox, and to develop physical AI-enabled robots. Each company uses its digital twin as a robot gym to develop, train, test, and simulate robots.
I kind of just want
or vision AI agents as they perform their tasks or work together as a diverse fleet. And when connected to the physical twin with IoT, each digital twin becomes a real-time interactive dashboard. Pegatron uses NVIDIA Metropolis to build AI agents who help
not inserted properly. You didn't do it right. You get executed.
Complex techniques. Taiwan is even bringing digital twins to its cities.
Isn't this just Google Earth? That's just Google Earth.
Linker Vision and the city of Kaohsiung use a digital twin to simulate the effects of unpredictable.
That didn't. Look at those crash physics. Those crash physics looked looking beautiful.
And build agents that monitor city camera streams, delivering instant alerts to first responders. The age of industrial.
What if someone is like just throwing it back and the AI thinks that's an alert?
It's so excellent. Well, it stands to reason that Taiwan, at the center of the most advanced industry, the epicenter where AI and robotics is going to come from, it stands to reason that this is an extraordinary opportunity for Taiwan. The largest electronics
Okay, so it looks to be that the entire conclusion was that Jensen showed us the 5060, showed a laptop, and then proceeded to never talk about it again. And another thing is, this actually kind of matches up with how things have been going lately with the RTX stuff, with the RTX 5060 precisely, because drivers weren't released for for media outlets and companies to review the product, and tomorrow the RTX 5060 is launching, and then they'll get the drivers. So what will happen is people will be really fucking disappointed because they're afraid to admit at the fact that the RTX 5060 is just the 4060 but worse. I don't think these are final specs, but who knows. If we'll take a look, I was planning to get this graphics card, but I didn't. I just went for the 4060. Yeah, it's gonna be 15% better, allegedly. The only thing that concerns me is this. I think the market will not like this because 12 gigabytes is on the B580 on this graphics card, and people really like this graphics card for the VRAM and the ray tracing capabilities. So if the 5060 won't deliver, people are gonna be mad. Wait a minute. Wait a damn minute. Wait. Did they just take... No. They didn't just take... Something's not right. Where did they put the... Wait. 5060. 5060 Ti 8 GB. So either this graphics card is really shit, or this graphics card is really good. But who knows? But still, 15%. Anyway, good night to the one viewer that's currently watching. I think I'm gonna call it quits here because my internet connection is currently dying real bad right here. And I'm gonna go sleep. Bye.